that. For anyone who is listening, I'm doing this at 5 o'clock on a Friday and I'm going a little nuts.
Part 2b, quadratic formula, numbers 11 and 12. I'm going to do 11, you're all going to do 12, just to practice. Solve each equation with the quadratic formula. You should know this by now, but the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. I have to identify, again, the first step would be to identify my a, my b, and my c. And then, second step is to actually put them into the formula themselves. Now again, by default, the formula, the b is negative. But in this case, my b is also negative. Two negatives will make a positive. So it is 5 plus or minus the square root. Now please, please, please put negative numbers in parentheses when you're squaring them. My b is negative 5 squared minus 4 times my a, which is 5, and my c, which is 5, all over 2 times my a of 5. Alright, that's step 2. Step 3, I'm going to simplify the discriminant, which exists underneath the radical. You can put this in your calculator as is, but do not include the radical. That won't give you the right answer. We're just going to simplify underneath and then rewrite it with the radical still there. If you do that, you should get, wait for it, negative 5 squared minus 4, parenthesis 5, parenthesis 5. You should get now a radical with negative 75 underneath it. So, at this point, that was my third step technically, so I guess I can identify that. That was my third step. At this point, I have to consider, we'll do it in green, this, my new radical. Is it a perfect square? Square root of 75 doesn't break down to a whole number, so no, it is not. I have to factor it, factor tree it. And this should jump out at you. You can't take a square root of a negative, so when I am done simplifying this radical, I need an I. An I comes out to represent that we're entering into the world of imaginaries. So, factors of 75. 2 isn't 1, 3 is 1. So, it would be root 3, and 3 times 25 is 75. Alright. 3 can't be broken down anymore, but 25 can. Into 5 and 5. 5s are done as well, but anytime I see a pair, I know that they come out as the number itself. So radical times radical, they cancel each other out. I'm just left with 5. So I'm going to rewrite the entire thing. This is step 4. Rewrite the entire thing. I have a 5, so 5 plus or minus the square root. Now hold on, because I just said that these come out, so it's 5 as the number itself. And I also said that because I'm taking the square root of a negative, I need an I that comes out as well. And the only thing left inside still is the radical 3. And this is all over 2 times 5 is 10. Now, at this point, there could be a couple different situations that occur. If all these were whole numbers, then I would actually have to do the math. 5 plus the whole number divided by 10, 5 minus the whole number divided by 10. But they are not all whole numbers because they have that radical still there. But I can still, I see this 5, I see this 5, and I see this 10. All three numbers have a factor that's in common. So if that's ever the case, you can divide them by that factor. In this case, the factor is 5. So I'm going to rewrite it in its simplest form. 5 divided by 5 is 1, plus or minus 5 divided by 5 is 1. I don't necessarily need this 1 next to the I, but I'll write it just for understanding purposes. Root 3 all over 10 divided by 5 is 2. And I am done. Now you try the next one.